Yeah. All right, so loops and files. What do we need to know? We need to know what plus plus does, which adds one to a variable. You can put the plus plus before the variable or after the variable, and they mean two slightly different things. If they're on a line all by their lonesome, they don't mean anything different. But if there's something like this, x equals plus plus y, that means something very different than x equals y plus plus. When the plus plus is before the variable, it's called prefix. When plus plus is after the variable, it's called postfix. And the difference is that if the plus plus is here, it's the very first thing that happens before anything else. So like if y here is equal to 10, then this line would immediately turn it into 11. And then 11 would get copied into x. Let's change this into a different letter though. Say a is also equal to 10. This copies a into x and then increments it because plus plus is postfix, meaning it's the last thing that happens. So the a gets moved into x and then a is incremented. So what is x in this case? Y was immediately incremented. It changed from 10 to 11. So at this point, x is 11. What is x in this case? It waits until everything is done before incrementing a. So x is equal to 10. After the code is done, then y is now equal to 11.
Can you do that one in while loops?
Yeah, that's what you use plus plus for, is for loops. That's pretty much why it was invented. And then in this case, a is also equal to 11. It's just the matter that we did two things in one statement that mattered, whether it was done first or last. If it's just on a statement all by its lonesome, like you do that, then it doesn't matter whether the plus plus comes first or last. But if you're assigning its value, it does. And we could prove that to ourselves. Time to grab our boilerplate. I believe we're on Lecture N. I could be wrong about that.
Yes, we are.
So it's an empty project. So when you make your new project, if you're following along, please do not choose console application. Choose empty project.
You guys people chose that before?
There we go. Grab my boilerplate from the modules.
And we're going to discuss the pre-made project stuff, right?
Which pre-made project stuff?
All of them.
I don't know what we mean.
The Win32 console application or something like that.
Oh, you mean the precompiled header? Yeah, that's kind of annoying. It's not really particularly germane to talking about C++ because it's not C++, it's Microsoft stuff that they've added to it. But it is worth talking about, so absolutely. So add a new item, lecture in .cpp, paste our boilerplate. All right, I'm going to make two variables called a and b, and I'm going to make two more variables called x and y. So int a equals 10, int b equals 10, int x equals plus plus a, semicolon, int y equals b plus plus, and then let's print them out. Cout less than, quote, a equals, end quote, less than a, less than ENDL. And then just copy and paste that for, a, b, x, and y, changing the letters as you need to. A, b, x, y.
Oh wait, I screwed up.
Like that. Alrighty. Now I made a mistake because they all printed out to 11. And I just gave you a great big speech about how that wasn't going to be true. Oh, do you see what I did wrong? I made an idiot error. Somebody can tell me.
They were all A's.
Yep. That genius at work. All right, how about we change those? There we go. Let's fix that and do that again. All right. So why is y equal to 10 when everything else is equal to 11? It's because of this statement. What's different about this one?
I made an idiot error. I'm just kidding.
That's me. All right. Parker, did you notice when I was talking about it, what's different about this one that made y equals 10, whereas x is equal to 11?
Well, it has to read, I think you said it has to read the postfix first, and then it returns it back and adds more to it.
Yep. If it's a prefix, it happens first. So a got turned into 11 and then stored into x. But if it's postfix, that's the last thing that happens. So b got copied into y, and what was b set to? 10. And then b got incremented. But if it's on a line by its own, it doesn't matter, right? If I do a plus plus and I do, plus plus b, who cares? Doesn't matter. This actually is like a nanosecond faster for some reason. It's because it only has to make fewer accesses to memory to perform that calculation, but not enough to really worry about. I'm going to delete those two lines. But yeah, you use those for while loops. Like a equals 10, semicolon. While, parentheses, a greater than 0, in parentheses. C out, less than, quote, or no quote, a, less than, quote, dot, backslash n, end quote, and then a minus minus, semicolon. And then when we get done with it, well, let's see what that does right there without running it. It's going to start off at 10, and then it's going to keep counting while a is greater than 0. So what's the last number we're going to see on the screen?
-1.
Not -1, because it's going to keep going while it's greater than 0. Excellent guess, because if it did get to 0 and then we subtracted 1 from it, it would get to -1, but it's not gonna. See, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Why? Because when it comes back up here and a is now equal to 0, this is no longer true. And so it falls out of it. But we could print a at this point, and then we would see what it is after the loop.
Oh, so when a equals 10, it goes back to the amount of positions.
Yep.
Okay.
So end quote, less than, a, less than, d and dl.
I'm on track in the lectures.
Yep, so this is like if, except while means that as soon as it hits that closing brace, it jumps back up and it reevaluates the condition. What if we took the a minus minus out? What's it going to do?
Make a infinite loop.
Yep, it's going to just repeat forever until we close the program. Yeah, so I'm going to undo that, obviously.
Wait a minute. There's some there's a legal class.
Yeah, let me come look.
Made an infinite loop. Now I'm just gonna let the program crash.
So in general, you have 3 steps inside a while loop. And you can change this as you need to, but you have an initialize step. That's the initialize right here, right? A is equal to 0. I mean, it already is 0, but whatever, right? And then you have a comparison step. So while a is less than or equal to 20.
You have another A variable.
Sure. I'm just using a variable again. No biggie. Okay, I can do B instead. So B is equal to 0 while B is less than or equal to 20. That's the comparison. I'm going to move these so that these comments are actually next to them instead of above them. And then inside here you have the body of the loop. Whatever we're going to do. In this case I'm just going to print out B. And then you have an update. So you initialize your so-called LCP, loop control variable. So that's your control variable in this case is B. You initialize it and then you compare. You can have your comparison there, your condition that involves the loop control variable. Why did I say P? Variable is spelled with a V, LCV. And then after you do something with it, then you update the loop control variable. Let's make it B plus equals 2 so it goes up evens rather than just by 1. And then you update the variable. Those are the 3 steps. Initialize, compare, update. That's your classic loop. Now not all your loops have to do that, but that's your classic loop. And we did the same thing on the countdown loop, right? Initialize, compare, update. Now we're going to write a loop that does the same thing. Well, let's make sure it works first. But it's going to be a for loop. So since we did plus equals 2, it didn't just go up by 1 each time. It went up by 2 each time.
What happens when you move the counter?
Pardon me?
What happens if you remove the counter?
Well, which part? Here, here, or here? Because if we remove that update, it's just going to be an infinite loop again. So let's write a for loop now.
Alright.
That does the same thing as the loop above it. For x equals 0, semicolon, x less than equal 20, semicolon, x plus equals 2, and then C out less than x less than ENDL. Notice that this for statement has all 3 parts. It's got the initialize, the loop control variable here. It's got the compare, the loop control variable there, and it's got the update, all in one syntax. That makes for loops much cleaner to write. If I take this word body out, I don't really need that there. You just know that the body of the loop is the stuff inside the curly braces. This for loop does the exact same thing as the 6 lines of code above it. Even if I put some curly braces in, it still looks a lot shorter, doesn't it? 2 lines of code to do the same thing that 4 lines of code took up here. So for loops are great for counting. For loops are great for counter-controlled loops. In other words, definite loops. A definite loop is a loop that counts over a definite series of values. You know the starting point, you know the ending point. Yes, sir?
Why can't you use mathematical operations inside the while in the while loop function itself instead?
Oh, you can. If you want to put some kind of math in here, sure, you can.
Well, you just said that the for loop will still be is easier.
It's just easier to write. If the loops are going to do the same thing, if it's a counter loop, that's an easier loop to write. But that's what for loops are good for. If you're writing some other kind of loop, other than a counter loop, a for loop makes less sense. And we'll be talking about the kinds of loops that for loops don't make the best sense. But honestly, there's nothing you can write with a for loop that you can't write with a while loop and vice versa. But if it's going to be a counter loop, if it's going to be a so-called definite loop, the for loop is usually the easiest way to write it. Doesn't mean it's a faster way, you know, it doesn't run faster or anything, but it's the easier way to write. The syntax is so clean because it shows you the starting point, it shows you the end point, and it shows you the loop control, how the update, all in one thing. Because there could be 10,000 lines of code here, right, between where the loop begins and where the update happens. But in this case, we know instantly with a single glance where the counter begins and where it ends.
Except if it's over 100 lines of code, a for loop for a counter loop is gonna be so freaking long it's ridiculous.
Yeah, you could put huge numbers of lines of code in either kind, but there's a rule of thumb kind of, which is that if a block of code is more than a page long or anything that'll fit on the screen, or 50 lines or something like that, you ought to try to break it up into functions. At that point it's getting too long because you can't just figure out what it's doing immediately. So if you have 200 lines of code inside the while loop or the for loop, it's time to start thinking about how to do it a little bit differently.
Make it into methods instead of...
Yeah, put them in functions. Yeah. So minus minus is the same thing as plus plus, except it subtracts rather than adds. It's called decrement. Plus plus is called increment.
Can Python do a decrement?
Python can only do plus equals 1 and minus equals 1. For some reason, the guy who invented Python did not do plus plus and minus minus, even though it's supported in a whole bunch of other languages. So Python's a really cool language, but I wouldn't have minded seeing plus plus and minus minus in it. So, if a nuance, you can write really complex expressions like this. I wouldn't. Why do I say that? Because then you have to worry about whether it's a prefix or a postfix, or which one's going to happen first and which one's going to happen last. But that's totally legal to write. Like, if we set, A equal to 10, B equal to 10, and we set X equal to plus plus A plus B plus plus. It works. What's X going to equal? Well, if the plus plus comes before the variable, it's called prefix. So what does that mean? It means it gets incremented immediately. So this is already 11. If the plus plus follows a variable, that's called postfix. So it means it waits until the whole statement is done and the semicolon is reached. So it's going to be 11 plus 10. So X will equal 21. Not 20 or 22 as you might otherwise expect. Again, the plus plus, the prefix and the postfix modes are coming to confuse us a little bit. One thing you'll see experienced C programmers do is something like this. X equals 0, semicolon, while, parentheses, plus plus X, or while X plus plus is less than or equal to 10. I'm just going to make it less than 10. And as a matter of fact, I'm going to put the pluses in front of it. I think that's the clearest way to do it. And then C out X. Now the update is right there, right? Kind of easy to spot, just like it was in the for loop. I tend not to do that, but it's perfectly good C programming. And it shortens your code by a line. If that makes sense to you, if updating the variable inside the condition works and you know exactly where it's going to start and stop. What is this going to print, by the way, guys? Is it going to start printing at 1 or is it going to start printing at 0?
Printing at 1.
Yeah, y'all got it. Good. I was hoping somebody would say 0 so I could act all smart and correct you. Good job. So the introduction to the loops, this is the expression, the comparison, followed by the statement. If the statement's only one line long, you don't have to put curly braces. So I didn't need curly braces here. But if it's a block of code, it has to have curly braces. And we know what it's doing. The expression is evaluated, and if it's true, the statement of the block of code is executed. And when that statement is done executing, it checks the expression again. And if the expression is still true, it does the block a second time and a third time and so on until the expression is no longer true. Fastest way to break a code. Put a semicolon there. Well, in that case, it didn't break it. But if I put a semicolon here, my program's going to hang. The reason why is because the semicolon is the same as doing this. Curly braces. There's nothing updating B, so it's an infinite loop again. So just like never put a semicolon after an if, never put a semicolon after a while.
Wait, it did an infinite loop that time?
It did. It printed this, it printed after the loop A equals, and it never did anything else. It ran that far and no further. It's in an infinite loop doing nothing, which is real useful, right? Because it's treated like this, right? And inside the curly braces, nothing is updating B, so there's no way it can ever exit the loop. Get lost. So it's called a pretest loop because the loop happens first. Excuse me, the condition happens first and then the body of code is executed. So a while loop is a pretest loop. So is a for loop. While loops and for loops are pretest loops. There's another kind of loop in this language that is not in Python called a post-test loop. Do loops are post-test loops, meaning that the test happens after the body of the code. Like this. Let's set x equal to 0, and then we're going to do something. We're going to print out cout x times 100 for whatever purposes. And then we're going to add 1 to x. And we're going to keep doing this while, parentheses, x is less than or equal to 10, in parentheses, semicolon. This is the only time that it's okay to put the semicolon after the while, because it's the last thing in it. So do loops, it's okay to put a semicolon after the while. Otherwise, never put a semicolon after a while, or else it goes into infinite loop.
Or stops the loop.
So here we go. I'm going to run it. What's it going to print out? That's not what I was expecting it to print out. Oh, I didn't put that at the bottom of my code. I'm going to cut all that and move it down to the bottom of my code. There we go. And so it's going to print, 0, 100, 200, 300, all the way up to 1,000. What would happen if I changed this to like 70?
It's going to go to that.
If it was a while loop, it wouldn't do anything, right? If I did this, while parentheses x is less than equal to 10, take that space out between the less than and equal to, then cout x times 100 ENDL semicolon, and then x plus plus. I'm going to delete this momentarily to prove the point. It's not going to print anything. Why? Because x is 70. It's not less than 10. It's like an if statement. Well, at this point, is x less than 10?
No.
No, so it's not going to print anything. And we can prove that. Except my program's already running, so I can't prove it. There it went. Didn't print out my hundreds. But if I rewrite it to be a while loop, it's going to print one thing. because x starts off at 70 and there's nothing stopping it from going into the loop. There's no gatekeeper, right? The test is at the end, not the beginning. So it comes down here and it immediately prints out 70 times 100. So it's going to print 7,000. And it adds 1 to x and then it checks it. Yo, is x less than 10? No, it's not. So it doesn't repeat the loop, but it does do it at least one time. That's the thing about do loops, is that since the test is done at the end, the body of the code is always executed at least one time. And that's not true of while or for loops. If you have a while loop and x is not less than 10, it won't even do that part. And so we're going to see 7,000 show up.
I'm going to ignore it.
Yep. Okay. So, while, excuse me, the important thing to remember about do loops. They are post-test loops. The test occurs at the end of the body. So the body is executed at least once, no matter what.
And there's an and loop.
Some languages have other kinds of loops. Some languages have do until or repeat until, but these are the loops we have available to us. Do, for, and while. So when do you use each kind of loop? Use a for loop for counters, definite loops, for a series of values. That's when you use a for loop. You're going through a series of values. You're going to count from 1 to 10. You're going to print out the elements of an array, right? It's a definite loop. You know the beginning point, you know the end point. Use a do loop if the body must be performed at least once. Otherwise, use a while loop. Now, those are just rules of thumb because honestly, there's absolutely nothing you can't do with any other kind of loop that you can't do with a while loop. That's why Python doesn't even have a do loop, is because if you wanted to use a do loop in Python, there's a way you could write a while loop to simulate it, right? You just put, I'm not going to even talk about it, that's Python. So you could use a while loop for absolutely everything, but these are rules of thumb. If you have a for loop, you may as well use it if the condition's right. If you're writing a counter or you're stepping through a sequence of values. Honestly, I almost never used do loops when I was doing my professional programming, but we'll run across times when it's appropriate, I'm assuming. Let's go a little bit further, maybe, and then we're going to do a review. Or when is our exam? Is our exam Tuesday or is it after the break?
Tuesday.
All right, so yeah, we will need to do a short review. So a while loop is a pretest loop because the test happens before the body is executed.
Is the test going to be hands-on or is it going to be multiple choice?
You said it was multiple choice.
It's all the above. It's multiple choice, it's matching, not much matching. It's true, false, and there's going to be a couple of places where you type in your own code.
Then you said you would actually guide us through the questions that day as well, or just, I thought I heard you one. I was like,
I'm not going to give you all the answers. Nah, y'all got to do it yourself. But there's a few places where you have to write, some code. If loops were on the exam, an example would be write a loop that counts from 1 to 10. Loops aren't on the exam, so obviously that question's not going to be there. But, write an if statement that, will print yes if A is less than 10. Well, you know how to write an if statement that'll print yes if A is less than 10. That kind of stuff. Otherwise, multiple choice and true, false, pretty much. So using the while loop for input validation. What does that mean? Enter a number less than 10, and they type it in. What if the number was greater than 10? Well, they're jerks, and we're going to yell at them. Invalid entry. Enter a number less than 10. I told you. And so they type it in again. Well, what if they're still a jerk and they type in 20? It's going to come back up here, make this check again. It's still true, so it's going to tell them, nope, wrong, do it again. And finally, they give us a good number. 1 is less than 10. Comes up here, it checks. Yeah, it's less than 10, and it's done. So that's an example of input validation. You can use a while loop to do input validation. You could also use a do loop. Do loop might be an even better way of doing it, because you would only have to put the cout and the cin in one place rather than in two. This is what's known as priming, a priming read. I don't know if this textbook calls it that, but the fundamentals textbook does. It's called a priming read because you read the number in once and then you test it, and if it's wrong, you read it a second time. So it's like priming the pump. You got to get a little bit of water coming out before you can get a lot of water. So you have your input here and your input here, and I don't particularly like that, so I usually write my loops in a different way, but it's a totally good way of doing it. All right, just a second. We're going to do the same thing, except slightly different, because we don't want to do the same thing that the PowerPoint's showing. We're going to tell them to enter a number that's even. And if it's not even, we're going to print an error message, and they're going to do it again. So we need a variable that'll hold our input. Int input doesn't even have to have a value. And let's get creative, and since they used a while loop, we're going to use a do loop. Do, curly brace. Let's tell them to enter an even number. Cout less than, quote, enter an even number, colon, space, end quote, semicolon. Cin greater than input, semicolon. Now we need to check. If it's not even, we're going to print out an error message. So if, parentheses, input modulus 2 greater than 0 or not equal 0, because we tried to divide it by 2 and it didn't have a remainder of 0, that means it's not an even number. It means it's an odd number. So in that case, we're going to print out our error message. Cout less than, quote, sorry, that's an odd number, period. Space, space. End quote, semicolon. Now since it's a do loop, we need to put our while at the bottom of it. So we're going to keep going while, parentheses, input %2 not equal 0, semicolon. So that's an example of an input validation loop written just a little bit differently. Now, just like I said, I don't like the other kind of loop because it has the input in 2 different places. I don't particularly like this loop because it has the condition in 2 places. And you can write one of these that has the input in only one place and the condition in only one place, but you have to use while true and then make a break statement in there. And so I'm going to skip that. Textbook doesn't show that. I mean, we'll do it, but just not today. Okay, so enter an even number, 111. Sorry, that's an odd number. Enter an even number, 223. Sorry, that's an odd number, 0. Yeah, and that was okay. So that's input validation. Input validation, loop until good data is read, or provided, or inputted, or whatever. Inputted does not sound right. I guess input is one of those verbs that the past tense and the present tense are exactly the same. All right, so just a sec. What we're going to do is we're going to make a function that calls itself. So that's almost like an infinite loop, except worse. So come up here and write a function, int test, parentheses in parentheses, curly brace, and then see out a message, see out less n quote, I hate tests, \n, end quote, semicolon, and then have the function call itself again, test. And then so if we go here and we put a call to test as the first thing inside main, it's going to print out I hate tests a whole bunch, but it's finally going to crash. I seem to have a mistake here. Test must return a value. Okay, change it from being int to void. Now run it. All right, and see it's saying I hate tests, but eventually it's going to run out of RAM. I say that. Yeah, it crashed. And the reason why is each time it goes into a function, it has to allocate a little more memory. And each time it leaves the function, it releases that memory. But it's only going into the function and it's never leaving the function. So it keeps grabbing a little bit more memory at a time, never releasing it until it's used up all the memory available to that program.
My function ain't working. Even if I put void.
Yeah, I'll come take a look. It's a valid programming technique, and let me show you a valid way of using recursion, except I can't get my debugger to stop. Stop. Okay, there. Nah, I'm not going to show a valid way of using recursion. We're just going to go on and worry about, I'm going to tack some notes on at the bottom. So I'm going to come down here. If you have these types, string, int, double, bool, and character. Say you have these. Single quote 0, double quote 0, false, the number 0 with no quotes, and 0.0. Which one of these is a string?
False.
Double quotes.
Nope, false is not a string because it doesn't got double quotes around it. So,
0.
like Serena said, it's that one. Which one's an int?
0 without parentheses.
That one right there, yep. Which one's a double?
0.0.
Yep, that one right there. And if we add now it's a cat. Okay, sorry.
Character.
We'll just delete that. All right. Which one's a bool?
False.
The false is the bool, and which one's the character? Single quotes. Yep, yep. So the difference between a string and a character is that a character has single quotes, apostrophes around it. A string has double quotes. And the more important difference is that a character can only be one thing long. If I tried to do that, it's no longer a character, and it would not compile. It'd be a syntax error. That's opposed to Python, where everything is a string, even if you put it inside apostrophes.
So there's no character in Python.
Yeah, everything's a string. So if you have this statement, 3 plus 2 times 2, as opposed to 3 times 2 plus 2, what does this one equal?
7.
Yeah, that's 7 because 2 times 2 happens first. And what is this one?
12.
Not sure about. Nope. Multiplication always happens first, right? So
Oh, it's 8.
it's 8. Yep, exactly. And so that's based on operator precedence. So you have, you know, this language doesn't have exponents, so we can't count exponents, but parentheses, and then multiplication and division and modulus, and then addition and subtraction.
Wait, isn't just exponent POW?
Yeah, but it's not an operator, it's a whole function, so I'm leaving it out. Right, that's exactly how you do exponents. Not sure what's going on here. Oh, I just happened to end my comment there. I didn't mean to. Okay, there we go. So, this is the order of operation, right? Multiplications, divisions, or moduluses happen before additions and subtractions, and that's why that's 8. And that's why that's 7, because the multiplication happened first. What's the silly phrase for this? P, and then multiplication and division, and then AS, and there's supposed to be an E for exponent, right? But there's not, so PMDAS, please excuse my dear Aunt Sally. If you feel like remembering that, great, I don't care. Just gotta remember that multiplication and division and modulus happen before addition and subtraction.
Please, my dear.
Yeah, please excuse my dear Aunt Sally. We should come up with one that doesn't have an E in it, but I'm not that clever. So what does modulus mean? It means remainder. So if you have 7 modulus 2, what is that? 2 goes into 7 3 times with a remainder of what?
1.
1, yeah. So that would be 1. What's 8 modulus 2?
0.
0. What's 0 modulus 2? Well, 2 goes into 0 0 times with a remainder of 0, yeah. What is 2? Trick question. 2 modulus 0. That's a crash. So we're not going to ask that one.
You know what? I'm going to do it right now.
Go right ahead.
And x equals 0. Crash equals 0.
Hey, Nate, you should make your own class for crash, okay? Call it the crash class.
Crash is undefined.
All right, if we're going to make a classic, crash is our program. So I'm going to come up here, and I'm going to do the word class, crash,
Why is it saying crash is undefined?
and then public colon, please void space, please underscore crash, parentheses in parentheses. And what does it do? It counts 2 modulus 0.
Oh my gosh. Really, man?
All right, now we're going to make it crash. So even above our call to test, I'm going to delete the test function. We don't need that one.
Oh no.
Then I'm going to make a crash object, right? So crash, I can't spell, C1 semicolon, and then C1 dot please underscore crash.
It didn't compile.
Oh, it's not even letting it compile. Cannot divide or mod by 0. Well, how clever of it to know that in advance. Okay, we're going to trick it though. We're going to do int x equals 0 semicolon, and then we're going to modulus 2 by x. Now the compiler won't know that we're modulusing it by 0 because it doesn't know that x is going to be filled in by 0.
This is going to be funny.
And it says that my file is open for writing. It's not. I don't know why I'm getting that error. All right, well, I'm at the point where it's not letting me recompile. I would have to close Visual Studio and get it to open again, but it might work for one of y'all. Did that work for anybody?
Well, no.
So it's just not compiling at all?
No, it's not compiling.
Oh. Go down here. Oops. Click the red stop symbol. Try that red symbol right there. Oh, great, you have something going on. This was a real bad idea. We wanted to crash. All right. We may have to quit Visual Studio entirely.
Oops.
We don't need that.
Sorry, gang. If Visual Studio's crash entirely, just kill it and restart it. I hope you know how to kill a program. You know, you launch the task manager and you find it in here and you right click it and you do end task. And of course you know that there's more than one way to get to the task manager. Okay, so if I'm going to ask you to write some code as part of the test, write a few lines of code that do this. So write a few lines of code that asks the user for the current temperature.
I'm gonna break it.
Uses CIN to store the input into a variable named T, and then prints out the temperature is followed by the value of T. Hopefully you could do that, right? Write a few lines of code that do that. When I say a few lines, that means don't put the boilerplate in, don't put int main, don't do using namespace. Just do this. Ask the user for the current temperature, stored in T, so you're going to have a C out, followed by a CIN, followed by another C out.
And also, you probably want to put a bad data check. I think you can only do that with an if statement, right?
So if you want to use functions like POW or ABS, which library do you include? Yeah, CMath. If you want to use things like min or setW, wait, it's not min, setW or set precision, which # include do you use?
That's include IOManip?
Yep, that's IOManip. Or # include IOManip. For things like CIN and COUT, what do you use? The very first.
IOStream.
Yep, IOStream, exactly. How about RAND and SRAND?
IOManip.
Nope. The random number generators are stored in CSTD LIB.
What is this CST libs? Or I know it's like the first part of it. What is it?
Standard.
Standard.
C standard library. Yeah.
I need to include that. You need to include that to our boilerplates.
It should already be included in your boilerplate.
Yeah, if you don't have it, you can add it to it. I think it's in mine. Yeah, or when I say mine, I think it's in our... Oh, you're right, it's not. Dude. All right. So, yeah, you're right. It needs to be in there.
Follow-up board? Thanks. Thumbs up.
Well, listen, I already have it in mind, so I can only speak for myself.
What?
So how do you declare an identifier in this language, unlike Python where you don't declare your identifiers? And just remember that identifier is a fancy word for variable. So how do you declare a variable? Any variable, like X, and it's an int, right? Int X. You have to give it a type followed by a name.
And maybe an equals.
And then you can do an equal if you want to initialize it too, right?
Or X equals 2.
Well, if you just do X equals 2 without putting the keyword in front of it, that's good Python, but it's not good C. It won't let you do it. You have to put the data type in front of it the first time you use it.
Oh. Fail.
like this. If I go into my code, and I tried to make a variable called, I better get rid of this crash stuff. There we go. If I want to create a variable called age, if I do that, it's not going to work. Why? It doesn't know what age is. Age is undefined. I have to give it a type.
I wish C++ could get rid of that.
Yeah, that's what makes C++ cool.
Yeah, you can define this as like, well, the only way you can actually define an age is in Python. That's it.
Yeah, this works for Python because in Python you don't have to declare your variables. Scripted languages like JavaScript and Python, you don't give data types. But compiled languages like Java and C++ and C and C#, you do give your data types.
Because your variables are already defined by a value, you give it what it is.
If you have two integers, one divided by the other one, it does integer division. And what does that mean? If you did this, cout 5 divided by 2, what's that going to do? Is it going to print 2.5? And the answer is no. What's it really going to print?
4.
It'll round down or round up.
It does round down. Yep, it turns it into an integer. An integer divided by an integer is an int. So 5 divided by 2 is 2.5. Rounded down is
2.
Yep. So what if you did this? X equals 5, semicolon, or int x equals 5, int y equals 2, and then you do cout 5 x divided by y. What's it going to print out?
2.
Exactly the same, because these are still integers.
Now what about double divisions?
They work just like you'd expect. Double A equals 5, double B equals 2, cout A divided by B, it's going to print out 2.5.
If it's a long one, it's going to do the same thing as
Ints. Long and ints, because a long is just an 8-byte int, and int, a long. Just teaching Java where there are no longs. So an int is 4 bytes, and a long is an 8-byte int.
Python, I think there's a long as well.
Yeah, so float is 4 bytes, and then a double is 8 bytes. If I give you an expression that looks like this, be able to convert it into C, right? So what's the real trick? You just got to put an asterisk between those two things. And when you do that divide, you better put parentheses around the bottom.
Well, you gotta define x, yeah.
Well, yeah, but assuming all variables are already defined. So if you have a couple of variable names like 1987 salary 1987, salary underscore 1987, salary space 1987, and let's say that, each one of these is supposed to be set to 10,000. 2 of these are valid and 2 are invalid. Which are invalid?
1987 salary and 1987 the space 1987.
Yep, the first and the last one are invalid because variables or any identifier cannot begin with a digit and they can't have spaces.
We don't know why.
Yeah, we do, because it'd be really hard to make the program figure out where the end of the variable was. Seems like they could do so if they were really smart, but I'm not. So variable names cannot start with a digit or include a space. Underscores are great, right?
Why is the not a digit? That's very interesting.
Yeah, that is interesting, but I guess so that they can make it so that if it sees a digit, it automatically knows a number is coming up. that's something they could fix if they wanted to. But a lot of languages follow those rules, including Python and Java and C++. Whoops. So if you say that something is a binary operator, no, that's wrong. Yeah. A binary operator requires how many operands? Well, what does binary mean? If decimal means 10, then binary means 2. Right? So what is a binary operator? It's anything. Addition, multiplication, equal, right? Because you have to have x plus y, or a times b, or c is equal to 3. Each one of these is a binary operator because it takes 2 pieces of data. To do addition, you have to have x and y. To do multiplication, you have to also have 2 values. To do equals, right, you got to have 1 on each side. If you have less than, you still have to have 2 things, right? X is less than 3, and so on. All of those are binary operators, and each one has binary 2 operands. So the operator is a symbol, and the operands are the things that the symbol works on.
Thompson, I think we only got 4 minutes.
Yeah, and I think we're about done with the review. 8. What is an 8-byte integer type? We just already talked about that. What is the 8-byte integer type? Long, yep. Which can hold the more precise longer value, a double or a long? Now long makes it sound like, it's better, but it's not. Double because it's floating point, and so it can hold more precise values, and since it supports exponents, it can support larger values. Casting. This will be about the last thing we review. And this is all stuff that's in the quizzes. If you do this, A is equal to int B. It takes B and it reformats it into the data format to be stored into A. But there's 3 syntaxes. This is Python style. This is old school C style. And this is C++ style. You don't got to do it, but it's the way that the experts would tell you to do it. Like that. So just memorize all 3 ways of doing it. You don't got to memorize all 3 ways, because if I ask you to do it, I'll let you do it any of those 3 ways. So just pick your favorite. Your favorite's probably that one.
Is that in C++?
Pardon me?
Is the Python way in C++?
It works.
Oh, it works.
Yep. Python, all 3 of these methods work in C++. I just called it Python to remind you that that's an option.
Okay, I have a question.
Yes, sir.
So static casting, it's just defining the int types, right?
Yeah. It's like casting wax, right? It takes whatever the wax is and it makes it a new shape. Well, the new shape of it is an integer.
Okay.
So if B is a double, it'll drop the decimal point off, right? It'll make it a whole number.
Okay. Yes.
All right, when should you use getLine? When should you use getLine? Answer A, for all input, or for B, when input includes spaces?
B.
Yeah. And you could kind of guess that because we haven't been using getLine hardly at all, right? And so you certainly don't need to use it for all input. That's what getLine does, is it supports input with spaces. Whereas if you just use arrow, arrow, it chops the data up and ignores the spaces. Right? The spaces separate the pieces of data. Alrighty. Last two questions. Set W as opposed to set precision. One of these requires you to call it every single time before every piece of data. The other does not. Anytime you want to change something about the data that's coming up, do you call set W once in order to set all of the data to be 10 characters wide, or do you call set W every time?
Set precision.
Set precision is the one that you call once.
Set W.
Once you do set precision, it's set, right? So set precision, call once, set width, call each time you need it. All right, we are done. No, we're not. But some of these are quiz questions that y'all should know. What's the difference between \n and \t?
\n is an end of line.
That's a new line, an end of line, and \t is a tab.
But we don't use it very often.
No, we don't.
Actually, not at all.
Alrighty, some of these are direct from the quiz, so I'm not going to ask you. We're done. Let's make a Dropbox so we can head out. Any questions? You can use your notes. You can use anything uploaded into D2L.
We can use our own quiz answers as well.
You can use your own quiz answers. I shouldn't. I should lock the quizzes, but I'll let you use the quizzes that you've already taken. And you can use your books and you can use your PowerPoints. You just can't use Google and you can't use each other. And you can't use Instant Messenger to ask a friend, right? So you think I'm kidding about that, but like I've said before, people have done that. Alrighty.
You can't use WhatsApp, the app that is basically hacking everybody's private information.